believe in yourself and everyone will believe you. With these golden words, let's begin the lecture. Today we'll be dealing with two topics, that is heating effect of current and next one is electric power. When it comes to heating effect of current, by the name it suggests actually कि when current is passed through an electronic device, it's get heated. Normally ऐसा होता भी है कि like you are putting phone on charging mode, after a longer period of time you will feel the warmth of mobile phone, you can feel that your phone gets heated. Why? Because of heating effect of current. Now what is the reason behind heating effect of current? For understanding this, we'll have to go flashback. We have to go flashback on a story which I have told you previously also, that suppose I am riding a bicycle and was riding very fastly. What had happened? I was met with an accident. जब मेरा accident हुआ तो was I be able to moving with the same speed now? No. Why? Because there is a loss in my kinetic energy. Same is the case with electrons also. When current was flowing through for a longer period of time through a conductor, what happens? Due to collision, resistance increases. Increased resistance decreases the kinetic energy. यहाँ तक is clear? Now I am going to introduce a new term, that is heat energy. What is exactly this heat energy? What happens? By law of conservation of energy, we know that energy can neither be created nor be destroyed, only transferred from one form to another. This kinetic energy has to be transferred into some another energy source so that this law does not violate. What happens? The kinetic energy which is being lost by the electrons is compensated by the heat energy which is being dissipated by the device. जितनी ज़्यादा heat होगा कोई भी device, it means उतनी ही ज़्यादा उसके electrons का motion है, उतना ही ज़्यादा उसका collision है और उतनी ही कम उसके अंदर kinetic energy है. It means heat energy is increased, means kinetic energy is reduced, so that total energy of the system remains same. With it, let's understand another heating formula which is actually known as Joule's law of heating. According to Joule's law of heating, it is said that heat produced by a particular device is directly proportional to the square of current flowing. That is, if current is increased, heat is increased. Heat is directly proportional to resistance. हो ही रहा है ये देखिए, resistance is increased, heat is also increased. That is, heat and resistance are directly proportional to each other, and heat is also proportional to the time for which current is being passed. Like जितने देर के लिए, जितने टाइम के लिए करंट इज पास्ड इन अ पर्टिकुलर सर्किट, उतनी ही ज़्यादा हीट प्रोड्यूस होती है. कंबाइनिंग दीज थ्री, वी कैन से हीट इज प्रपोर्शनल टू आई स्क्वायर आर टी. एंड अगेन व्हेन प्रोपोर्शनैलिटी साइन जब हटेगा तो इक्वल्स टू, एंड देयर विल बी अ constant. In this case, constant is K I square RT. Let's take the value of K as 1. So what we had found, H is equal to I square RT, which is Joule's law of heating. This is Joule's law of heating. Now, there must be a question arising in someone's mind that why, if K is 1, we have to take the value of K as 1, then why we had put K here? Because we are following the rule of removing the proportionality sign, which is that whenever a proportionality sign is removed, we have to put two things, that is equals to along with a constant. So we had put constant K over here and the value of this constant K is 1. So we'll get H is equals to I square RT. This is Joule's law of heating. Now let's move on to a doubt which must be arising in some of the minds. That is, if we say H is, that is heat is proportional to I square RT, it means heat is proportional to I square also, and heat is also proportional to R. By using it, we can say that I is proportional to R, that is I or R इस केस के अंदर directly proportional हो गए. But what we have said that they are inversely proportional. Like when current increases, resistance is decreased. So is it wrong? It is not actually wrong. We cannot derive this relation with these two relations. Why? Because heat is proportional to square of the current only when resistance and time are constant, and heat is proportional to resistance only when we assume that current and time are constant. Like we have to find out I square, we have to work on I, that is we have to work on current. So we will be taking the relation of heat and current, keeping in mind that the next two terms should be constant, and if we are talking about resistance, so we have to just keep in mind that the other two terms, that is current and time, should be constant. We cannot say it's never that current and resistance are directly proportional to each other. They are not, and we cannot even derive this with the help of this relation. Now for solving numericals, we have a very basic derivation, a very generalized derivation. Just look here. We know V is the potential, that is equals to work upon Q. This formula is known to us. By it we can calculate work as V into Q. We also know that current is Q upon T, that is charge upon time. From here we can find out the value of Q and we'll get as I into T. We'll be putting this value of charge here, getting W is equals to VIT. We assume that this is our first relation or the standard relation. With this we can calculate two more relations. We can derive two more relations. That is, if we will be putting Ohm's law here, V is equals to IR, put the value of V here, you will be getting IR into I into T, that is I square RT, which is the second relation. It is also work. Don't get confused. ये तो heat का भी formula होता था, तो because work, heat, electrical energy लगभग same है. Numerically, we used to say that they all are same. Why? Because everyone's SI unit is joule. Everyone is a form of energy. So we can say that ये वाला formula heat proportional to I square RT standardized way में अगर हम बात करें तो is Joule's law of heating. But अगर किसी question में I square RT लगाना हो but work पूछ रहा हो, तब भी you can put this formula without hesitation. Why? Because work, heat energy, electrical energy, any form of energy को हम numerically लगभग similar plot करते हैं. Now, work is I square RT, the second formula we have derived. We have to derive the third formula. Just look over here. We also know by Ohm's law, I is equals to V upon R. Putting the value of I in the again standard equation, we will be getting work is equals to V into V upon R into T, that is V square upon RT. We got equation 3. We have got 3 different equations of work. Let's use them in numericals and just know them how to use. But the important thing you should keep in mind is their SI units. When you are solving a particular numerical, the thing kept in mind is everything should be in SI unit. Maximum time mistakes have been done. मिलीएम्पेयर दिया जाता है एग्जाम में तो गलत हो जाता है because हम मिलीएम्पेयर से सॉल्व कर देते हैं and टाइम आवर्स में कई बार गिवन होता है एंड हम सेकेंड्स में कन्वर्ट नहीं करते, तो स्टैंडर्ड एसआई यूनिट्स पे ध्यान देना बहुत जरूरी होता है. लेट्स डू अ न्यूमेरिकल टू अंडरस्टैंड द फॉर्मूला. Question is an electric iron of resistance 20 ohm. First we have to write given. Resistance is given as 20 ohm. Takes a current of 5 ampere. Current given is 5 ampere. Find the heat developed. Heat is being asked here. Time given is 30 seconds. Everything is present in the SI unit. Resistance in ohm, current in ampere, time in seconds. Very good. बहुत ही खुश होना चाहिए अगर ऐसा क्वेश्चन आ जाए तो. It's very easy to solve. Now, just check which formula we have to put. In the very first formula, V, I and T should be there. We don't have V over here. Can't be. This formula cannot be used. Now, check the second formula. I we are using here. R we have. T also we are having. So what we'll be doing? Simply we'll have to put the formula and get the answer. How are we doing it? Heat is equals to I square RT, that is 5 square into 20 into 30. 20 into 30. 25 into 20 into 30, that is 25 into 15,000 joule is the answer. This is how you can solve the question. The only thing you have to identify, actually these questions are very easy to solve. The only problem which comes in this question is the SI unit. Because if you are able to know what things are given, what is being asked, you have to just tally the formula कि कौन सा formula लगना है. For ये tally करने के लिए भी the formula should be learned on tips. Only then you will be able to get कि अच्छा ये formula लगना है. You will put the formula correctly along with along with correct SI units and you will get the answer. Before moving to the next topic, that is fuse, we have to know what are the practical applications of heating effect of current. Now you must have seen electric iron, electric geyser, electric toaster, electric rods. All these are based on the principle of heating effect of current. Why? Because in these what's happening? Current is being passed and the devices are heated and that heat is being utilized for our work. So we cannot say that heating effect of current is always a curse for us. We are using it for getting much more benefits in terms of ironing the clothes, in terms of toasting of a bread and other things also. This was the practical application of heating effect of current. Now we have to deal with what is fuse. All of you must have listened कि कभी ना कभी ऐसा बोला जाता था, because अब तो we are not using fuse actually, कि fuse उड़ गया होगा. This word fuse उड़ गया होगा. What is meant by this? See what happens and what exactly is a fuse. Fuse is a safety device. Fuse is a kind of soldier. As soldier used to stand on the border for a longer period of time, for days and nights, and what they do, as soon as enemy tries to come inside the boundaries of our country, they used to fight with that particular enemy. They can get injured also and can even die. Same is the case with fuse. Fuse is a kind of wire. There is a wire in fuse and that wire is being used as a safety device. How? Because before a circuit, this fuse is placed. If current is entered in the circuit within the particular range, then the fuse allows all the current to pass through it. But if in case current is entering the circuit exceeding its normal value, what happens? Fuse wire melts because of heating effect of current. Heating effect of current की वजह से fuse wire melts and this melting of fuse wire breaks the circuit. Circuit becomes open and the current does not pass through the circuit. And if the current is not passing, what happens? All the devices are now safe. For example, soldiers are keeping their life in risk always just for sake of us, just for sake of circuits. Similarly, fuse is at risk always as soon as current exceeding its prescribed value or nominal value enters the circuit. Fuse wire stops that current, keeping all the devices safe, otherwise everything would have been fused. This is the function of fuse. There is a copper wire in the fuse, and as soon as current enters into the particular circuit, this fuse wire melts if the current is increased or the current is above the nominal value. Now what happens? This is a drawback of fuse wire actually, कि melt हो जाता है. क्यों? Because if in case a wire melts, we have to replace a new fuse wire in it. Only then our circuit will again lights up. अगर फ्यूज उड़ गया आपका, जैसे आप अपनी लैंग्वेज में हम बोलते थे कि फ्यूज उड़ जाता है या फ्यूज खराब हो जाता है, it means what? It means that circuit has been opened, lights are now off. If you want to fix it off, you have to put a new wire over here, and in order to make the circuit light up. So this was a drawback with fuse, which was being compensated with a new device which is known as MCB and is used in maximum of the homes nowadays. See, MCB, full form is miniature circuit breaker. What is the benefit of MCB? MCB is also a safety device as fuse is, and the important factor, the disadvantage of fuse, that it has to be replaced. This disadvantage have been compensated by MCB, because in case of MCB, you need not have to replace the MCB as soon as it's stripped off. आपको बस थोड़ी देर बाद वापस उसको उसकी एडजस्टेंट पोजीशन पे रखना होता है, उसके बाद वो अपने आप लाइट अप हो जाता है. ऐसा नहीं होता लाइक इन फ्यूज की वायर हैव बीन मेल्टेड, यू हैव टू रिमूव that particular wire from the fuse, that melted wire, and then you have to put a new wire. All this phenomena had been removed in case of MCB. As soon as maximum current flow in a circuit, which can fuse all the devices, what will happen? This MCB gets stripped off, breaking the circuit. When this MCB gets stripped, light will get off. After a particular period of time, you just go and you just have to trip the MCB up in order to get the circuit working in proper condition. This is fuse and MCB. You know, domestically we use fuse of 1 ampere, 2 ampere, 3 ampere, 4 ampere, sometimes 5 ampere and 10 ampere, and others also these days. If in case a current is passing of 4.5 ampere in a circuit, and we want that all the devices in that circuit are within the range of this current only. If the current of exceeding 5 ampere enters in a particular circuit, what will happen? The devices will get destroyed. So what I have to do, what I have to do is I have to put a fuse of 5 ampere. जब मैं 5 ampere का fuse लगा दूंगी, अब क्या होगा? As soon as a current exceeding the value of 5 ampere enters the circuit, what will happen? Fuse wire gets melted, और जब fuse wire melt हो जाएगा, circuit gets open, and all my devices are now saved from getting destroyed. This is the benefit of fuse. Now, next topic is electric power. When we talk about the word power, power means what? Ki how much work I can do in a particular amount of time. That is, I can say definition as power is rate of doing work. That is rate of doing work. Rate आपको बताया था, rate means divided by time of doing work, work in numerator, is known as power. Let's derive the SI unit of power. Works unit is joule and time is expressed in seconds. That is joule per second, जिसको हम combine करके we used to say as watt. and is represented by W. It's watt. If I am saying there is a device rated 2000 watt, it means this is what? This is a power which is given in a particular question, because watt is the SI unit of power. From this we can derive one more thing, that work is equals to power into time. Work or energy or heat, we can say anything, आपको पहले भी बताया था. We can get from here that energy is power into time. What is the unit of energy? It's joule. कई बार क्वेश्चन उल्टा हो जाता है, like power and time given होता है, you have to find the energy. So one thing should be kept in mind, that energy or electrical energy should be in joule only when power is in watt and time is in second. If it's not, you have to convert it. Like sometimes power comes as kilowatt. So 1 kilowatt is equals to 1000 watt. You have to use this expression for converting kilowatt and into watt. This is actually the basic of electric power, but there are some formulas also which we can derive from this particular power formula. That is, we know work is I square RT. So we have to find power from this formula, work upon time, that is I square RT upon time. We can cancel out time by time and we'll get the formula of power as I square R. This is the first formula of power. Second formula of power is V into I. And the third formula of power is V square upon R. कहाँ से आए ये फॉर्मूलेस? ये फॉर्मूले आए हैं, एनर्जी इज I square RT था, एनर्जी इज VIT था, and energy is also equal to V square by RT. From these three formulas, we have generated power, because power is energy upon time. When you will divide time by all three formulas, you will be getting these formulas. Like we are having 4 formulas of power, these 3, and the other one is work upon time. Let's do the numerical to understand it more clearly. An electric bulb is connected to a 220 volt generator. What is given here is 220 volt generator. The current is 0.5 ampere. Current here is 0.5 ampere. What is the power in it? Power is asked. There are actually 3 formulas of power in terms of जब V given होता है या I given होता है, whatever. So check which formula should be used. It's very easy. V and I are given. R is not given to you. V and I are given, but R, that is the distance, is not given to you. So these 2 formulas will not be used. The only formula left is P is equals to V into I. You will be putting the formula and will get the answer. Power is 110 watt. This is the answer. Don't forget to put the SI unit, otherwise you will lose the marks. This is actually electric power. Let's move on to a next topic, that is last topic of the chapter, and is commercial unit of electrical energy. See, we know that power is energy upon time, or we can say work upon time. From here we had calculated energy as power into time. Now energy's SI unit is joule, provided that power is in watt and time is in second. I have discussed just now only. But commercial unit of electrical energy means what? Which is being used in finding out bill for a particular home. Electrical bill, बिजली का bill आता है आप लोगों का. For it, commercial unit of electrical energy is used, which is actually kilowatt hour. You can find in your meters also, electrical meters you are using, you can find there in the extreme right side on the top, kilowatt hour is mentioned. So what is it? It is the commercial unit of electrical energy. And when we have to use the commercial unit of electrical energy? When power is in kilowatt, time in hours. If in case a question is given that you have to find out the value in terms of commercial unit, you have to find out the value of energy in terms of commercial unit. So you have to keep in mind that power should be in kilowatt and time should be in hour. Only then you will be getting the answer in kilowatt hour, which is the commercial unit of electrical energy. If you will be solving directly, like you will be doing like this, and the answer you are giving as kilowatt hour, it's wrong. If power is in watt and time is in second, energy will always be in joule. If you want your answer to be kilowatt hour, energy should be checked once again that power you have put in the particular formula is in kilowatt and time in hour. Otherwise, your answer will 100% be wrong. Nextly, what is the relation between these two units of electrical energy, that is joule and kilowatt hour? Let's check. 1 kilowatt hour ko, if we want to convert into joule, we have to convert first kilowatt into watt, that is 1 kilowatt is equals to 1000 watt. Then hour, for joule time should be in seconds, so this hour should be converted in second. We know 1 hour is equals to 3600 seconds. So putting 3600 seconds here, you will be getting the answer as 36 into 10 ki power 5 watt seconds. What is watt and second? Multiplication of watt and second is joule. So you will be getting 1 kilowatt hour is equals to 36 into 10 ki power 6, it's 5 joule. We can shuffle it off and we can get 1 kilowatt hour is equals to 3.6 into 10 ki power 6 joule. This is the standard relation between kilowatt hour and joule. I'll repeat once again. We know 1 kilowatt hour ko, if we want to convert into joule, we have to take power in watt and time in seconds. So power in kilowatt should be converted into watt, as if 1 kilowatt is equals to 1000 watts. 1 hour is equal to 3600 seconds. Multiplying them, we will get 36 into 10 ki power 5 watt into seconds. Watt and second ka product is known as joule. We are solving it, we will be getting 3.6 into 10 ki power 6 joule, which is the exact and standardized relation between kilowatt hour and joule. That's all for today. Tomorrow we will be dealing with numerical portion of this particular chapter. Thank you.